Hi guys, happy Friday! We've made it to Friday. It's October. We have out Halloween decorations. It's fall weather. Get out your pumpkins and your pumpkin spice. And we've made it through a really long week, so we need to celebrate. And I wanted to make a short video to say thank you for working so hard on the Igneous module. I know it was tough, and thanks to the amazing feedback you guys have provided, I understand and know that we need to pause on the Igneous piece. I need to highlight some main ideas for you. And then we're going to postpone the test. For those of you that were looking at the calendar earlier, you saw that our Igneous test originally was going to be today. Well, we're not ready for that. So I've moved it to Wednesday, and let's set that as a goal. I think that if we pause and highlight these areas of difficulty, by Wednesday, we're going to be ready for the test. So if you will stop looking at me and look at your screen, I have shared with you some Igneous Rock notes. These can be found under the study guide button from our homepage. So they're yours to have as well. But I thought going through them verbally will help some of you that are confused. Igneous Rocks notes. These are one of the three types of rocks that you have been studying since third grade. Particularly, igneous rocks form when something melted or molten cools and hardens. The fancy word for that is solidify. So when magma or lava cool, they're no longer that molten or melted material, they are solid. And if it has cooled down from magma, that means, if you read right here, it was inside the earth, underneath the ground. So that is going to be a certain type of rock. If it cooled from lava, like an actual volcanic explosion, see like this volcano right here, then it's going to be another type of rock. Let's throw in some fancy words. That type of rock that cooled underneath the earth, we're going to call that intrusive. Think inside the earth, intrusive. See here in your bullet point, it's rocks that form from magma, so inside the earth. I could get even fancier and use the word plutonic. They all mean the same thing. Intrusive rocks, plutonic rocks, rocks from magma, they're all the same thing. So I've got all these words lumped together for you. Because they cooled inside the earth, they cooled slowly. Think of an oven. If you're baking cookies or lasagna, whatever in the oven, and you keep that door closed, it takes a long time for that oven to cool down, right? If you open the door and bring things outside, they exit the oven, it cools faster. So inside the oven, inside the earth, which is like an oven, things cool slower. And because it's cooling slower, there's more time for things to grow, like crystals. So you can get big crystals, or the fancy word is coarse-grained. Fun examples of these are granite or diorite. Let's talk about the opposite of that, your extrusive rocks. Those are the ones that form from lava. So the molten material has come outside of the earth, and now it's cooling off. So it's lava, and the fancy word for that is volcanic. All those three words mean the same thing again. Extrusive rocks, volcanic rocks, lava rocks. They've all formed outside of the earth. And because they're outside, they can cool much quicker. And because they cool quickly, there's not as much time for crystals to grow. So you might have teeny tiny crystals, or sometimes, like in the case of obsidian, it cools so fast that no crystals get to grow. So you get that awesome glassy appearance. Examples of extrusive rocks, like I said, are obsidian. There's pumice, scoria, lots of cool things. If you can see either the lack of crystals or sometimes air bubbles, those are good indicators that you're dealing with extrusive rocks.